Another question that I kept on getting asked 5 years back when I started raising these things at Delhi, where will we get our material for batteries? Lithium. We do not make lithium in India, we do not mine lithium in India. Are we going to import like we are importing petrol? Where are we going to get nickel? Where are we going to get manganese and graphite, cobalt? I looked, we really do not have all these things in India, unfortunately. Of course, petrol is imported and consumed immediately. These will be used for some time, but still it will be very import dependent. So, this was a troublesome question, and people sort of say no point in moving towards electric vehicle. These are all people who are trying to stop electric vehicle. And that is the time we sort of said that how is battery made. First thing is battery pack is made. A vehicle uses a battery pack, a full battery pack. It is actually made of cells, and there is something called cell to pack manufacturing. It costs about 35%. It involves it's quite complex. People sort of say, oh, this is just PR assembly. People did not understand. It involves thermal design, it involves mechanical design, it involves very careful electrical design and a battery management system to ensure that it never becomes unsafe. All this we are going to do in detail when we do the battery chapter. The next thing that it requires is a cells. Cell manufacture is a little bit more like chemical engineering, it is a 20-25% value add. But the most interesting thing is I told you that cells keep on evolving, year after year the cost comes down, energy density goes up. So, cell manufacturing is what it will impact the most, because you will have new chemistry. If you use old chemistry, your cost will be high, your weight will be high, size will be high. So, this is where you really require technology. You probably have to get into partnership with somebody and start and then develop technology. And then of course, battery materials. I talked about battery materials is important, mostly imported. This is where we started looking at it. Yes, our battery usage is going to go up and will require more and more lithium, cobalt, manganese, nickel and graphite. India does not have much of this, import bill will skyrocket. And then we said, well, we all use cell phone. There are 1.5 billion cell phones in India, more. We throw 400 million cell phones every year, 300, 400 million. We had the other day talking to Foxconn and they were telling us, and they have a battery. What battery do they have? Lithium ion battery, small battery, but is there 300, 400 million. What if I take those batteries, can I extract material? Is lithium, cobalt, it is actually LCO, so lithium, cobalt is very heavily there, others are there to a less extent. Do they get exhausted? No, these are materials, they remain. The battery has gone down, but the material is still there. Can I extract those materials in an environmentally friendly manner? Can I then reuse it for new batteries? This requires recycling technology, very, very important. And we have 400 million cell phones being thrown every year, enough for our initial thrust in electric vehicles and for new cell phones and things like that. Then we have laptop batteries. What do we do with that? Can we take that and recover the material? So, even though we do not have mines, can we have what is called urban mining? can I recover all the material? Of course, I have to do it at near zero effluent. I can't pollute, and this requires a process to be developed, but if we do that, we can get enough lithium and manganese, and of course one time we may have to import, but then we can reuse it and reuse it and reuse it. Almost you can recover 90% of the materials and reuse it, and we can actually develop this technology, become very good at it, and become the urban mining capital of the world. This is a very big opportunity, probably one of your biggest opportunity for that scaled commercialization, only if you are ready to do it. Another few minutes, one more chapter. What are the EV subsystems? I have done this part of it in the first lecture, and therefore just want to quickly go through it. The internal circuit, internal combustion engine drivetrain to EV drivetrain. The common parts are body, frame, common. Of course, you may want to make it lighter. You don't need that heavy because you don't have this power engine and all that. Doors and power windows will be common, wheels will be common, suspension system will be common, power steering systems will be common. Of course, if you are using hydraulic based power steering, that will change, but new vehicles are using power steering. Similarly, power brakes and all that. Power braking system will be common. Again, if you are using hydraulic, that will change. Safety systems, all airbags and parking sensors, all wipers, fluid pumps, mirrors, interiors, seats, everything is common. So, there is a lot of common things. What change is only the drivetrain and the fuel source. The parts which need to be modified, not completely thrown out. Air conditioning system. Air conditioning system conventionally used to be driven by hydraulics. What happens? The engine drives the wheel or a motor, engine drives the drives, and from there hydraulic actually convert it to driving the air conditioning system. Now we can drive air conditioning system directly by electricity, by a motor controller. So, we will have to develop motor and controller, which is by the way already happening in many of the modern vehicles of even the petrol vehicles, because they normally have a battery and that is driving it. Cooling system, just like air conditioning, cooling for any other item. If there is heat, then cooling. Electric batteries, for example, may require cooling, motors and controllers may require cooling. Dashboard may need some modification, more electronics is coming. Anyway, that change is already happening. So, these are the modifications. Parts to be removed and thrown away. Fuel tank we will no longer require. We will no longer require the engine. Clutches and transmission to be removed, because we are unlikely to have so many gears. ECU connection and other sensors, fuel pump and other engine subsystems. These are the things that will be removed, and parts which are going to be added, the most important part is a motor and a controller. This is something that we need to make it high quality, make it really highly efficient, and then of course transmission system, high efficiency transmission system. Single gear will be required, but you may require something more than that, and battery pack with BMS, very important. And then all the IoT and telematics. Well, these are done in conventional vehicles also. Today it was not there 15 years back, now it is there. You have to actually adapt it. You can do it more easily, because anyway everything is electric here. So, that is what is needed. You will need what is called DC-DC converters. Now, what happens instead of hydraulics, you are starting with certain voltage, as was mentioned, you may use some lower voltage. So, you need DC-DC converter, no big deal. You will need vehicle control unit, master control unit, etc., etc. Some isolation circuits, charging infrastructure instead of petrol pump infrastructure or swapping infrastructure, and of course With today's vehicle you do more in software, remote monitoring, which is again you will do it for petrol vehicles as well as electric vehicles. So, this is what will make ICE to EV. You have to all the time also worry about regeneration. This is again work going on for last several years, before even electric vehicle. You regenerate energy. That is where R&D is required. Needs motor design to recover as much of energy as possible. So, even when you are slowing down, motor should act as a generator and do that. Can regeneration efficiency comes close to 90%. This is our goal. Today it is much lesser. In which case we have to only worry about rolling resistance and aerodynamic drag, which I will talk about it. Materials for lightweighting vehicles, that will help a lot. Materials for better insulation to reduce heat load. So, our air conditioning competes with drivetrain for battery power. Better tires, better aerodynamics, wheel control and software. Can we gainfully redesign every part of a ICE vehicle for electric vehicle? That is the goal that we have. To conclude my section 1B, time is of essence. In 4 years we will be flooded with imported EVs. We have 2 years to design and manufacture EV system. We need to worry about what can we do in first year, second year, third year, not just develop but commercialization and scale. What do startups should do and what should educational institutes R&D should do? How do industry and academia work together? What we need from government? What is the role of the government? A question that has been thrown often to me, can we do most of it by 2030? I believe certainly. And if you want more details, look at the 2 articles. This was an article that I published about now 3 years back, 2018 December, nearly 2.5 years back, in IEEE Electrification magazine. It describes things in much more detail what I was talking about. There is also a blog that I have, that I wrote long back, again 4 years back, Understanding the EV Elephant. Why did I call it Understanding the EV Elephant? Because in the government 7 departments were trying to drive that, and each of them were driving it in a different manner and different ways. Any logic will not work, sense will not work. And I remembered a story that I had heard during my childhood, and all of us have heard it, 7 blind men and the elephant. All understood electric vehicle like those blind men understood the elephant. Somebody who touched the trunk and gone to Germany and seen something, they think that's an electric vehicle. Somebody has gone to US and seen something, somebody has visited Tesla, somebody has gone somewhere in Japan and they thought that was electric vehicle, and all policy was coming from there. The politicians were more or less following that. It was a very difficult experience, because we are trying to make what makes sense for India, what I have tried to share in this introduction. Nobody was listening to us. They did not. They are listening to the experts in the West. They don't listen to expertise in India, particularly academic, neutral expertise, which really wants the country to develop. This is a problem of India, can't do much about it. But that time, I think I wrote this article, this blog, out of a little bit of frustration, but I actually got into great detail what makes sense. How do you understand the EV elephant? That's an easy, and I think a large number of people who went through this, still there, you should still go through it. Slightly dated, but by and large it's true. At that detailed calculation what makes sense, what I have tried to put in this introduction. Hopefully with this you will be able to understand that and do things better. There are various references that I am giving to you. There are various reports that we have tried to write. We have tried to publish something, and hopefully that will help you understand electric vehicle. From next week onwards, we are going to start with how does vehicle work. what are the forces that make it work, and we will do that. Thank you very much.